Good morning, students. The next part of this topic is cycloalkene. Introduction. Carbocyclic compounds. Carbocyclic compounds containing one double bond in the ring. Carbocyclic compounds containing one double bond in the ring are called as cycloalkenes. कार्बोसाइड मीन्स कार्बनची सायकल ज्या कंपाउंड मध्ये असते व त्या कंपाउंड मध्ये त्या रिंग मध्ये एक डबल बॉन्ड असतो अशा कंपाउंड आपण काय म्हणतो सायक्लोअल्केन्स. सो दीज आर कॉल्ड द सायक्लोअल्केन्स. दे आर आइसोमेरिक विथ डाइज एंड अल्काइन्स. What do you mean by isomeric? That is that they have the same general formula with diene and alkyne. That is, they having the general formula CnH2n minus 2. So this is the general formula for the cycloalkenes, dienes and alkynes, and therefore these cycloalkenes are called isomeric with dienes and alkynes. Okay. Now the nomenclature. Their IUPAC names are derived by adding prefixing cyclo to the name of a cyclic alkene. The word cyclo is attached before the name of a cyclic alkene. Okay. For example, cyclohexene. Now there are the 6 carbons in the form of cyclic. And 6 carbons, therefore it is called the hexene, and it is in the form of cycle, therefore it is called the cyclohexene. So the word cycle is attached before the name of a cyclic alkene. So this is the IUPAC name system of cycloalkene. Now preparation methods. Preparation methods. Number 1, from cycloalkanes. Cycloalkane is then cyclohexanol is an example of cycloalkane. Now when cyclohexanol heated with 85% phosphoric acid at 440 to 445 degree Kelvin or with concentrated H2SO4 at 413 Kelvin, it gives the cyclohexene. Okay, the cyclohexanol on heating with this 85% phosphoric acid at 440 to 445 degree Kelvin or concentrate H2SO4 at 413 Kelvin, it eliminates the water molecule. How it eliminates the water molecule? There from this adjacent carbon there H. There is the removal of this H. This bond is transferred OH minus and this is the H plus, and this bond is transferred here to form a double bond. So this H plus and this OH minus combines their minus H2, and this bond between carbon and hydrogen is transferred in between these two carbons. Therefore, here a double bond is formed, and we will get the cyclohexene. So this is the first method from the cycloalkane. Now the second method is dehydrohalogenation of cyclohexene bromide. So dehydrogenation means D means removal of hydro means hydrogen and halogen. Removal of hydrogen and halogen from the adjacent carbon is called as the dehydrohalogenation from cyclohexene bromide. Now when the cyclohexene bromide heated with alcoholic KOH, it gives the cyclohexene. Now in this reaction also, that at the adjacent carbon there is hydrogen atom. Now this is a Br minus and this is the H plus. Now this bond is transferring between these two carbons and that carbon-carbon double bond is formed. So here minus HBr. So we get the when cyclohexene bromide heated with alcoholic KOH, we get the cyclohexene. So this is the second method for the preparation of cycloalkenes, that is the dehydrogenation of cyclohexene bromide. The next part of this topic is chemical reactions of cycloalkenes. So first chemical reaction is evaporation. Evaporation means addition of oxygen atom in carbon-carbon double bonded. So when cyclohexane is treated with perbenzoic acid, it gives the 1,2 epoxy 1,2 epoxy cyclohexane. 1,2 epoxy cyclohexane. Now this is the cyclohexane. There is the addition of perbenzoic acid. That is there is a one oxygen atom is added in between carbon-carbon double bond. This oxygen atom is added in between carbon-carbon double bond. Now plus this remaining C6H5 is COOH. So this is the benzoic acid. So only one oxygen atom is added in between these two carbon atoms. We will get a 1,2 epoxy cyclohexane. Okay, so this is the first chemical reaction, that is the evaporation. Now the second chemical reaction is the allylic substitution. Allylic substitution, when cyclohexane reacts with bromine at high temperature in the presence of light. Now this cyclohexane reacts with bromine at high temperature in the presence of light or with N-bromosuccinimide, NBS, N-bromosuccinimide in light to form the 3-bromocyclohexane. So only there Br is added at the third position. Now this is the 1, 2, and this is the 3. This is the 1, 2, and this is the 3. So this is the 3-bromocyclohexane. Now plus what? Plus HBr. From this carbon one H and one Br combined to form the HBr. And at the place of this H, there Br is attached. So there is the formation of 3-bromocyclohexane. So these are the two chemical reactions of cycloalkene. So this part cycloalkene is completed here. Okay.